Hello people. I think you saw my last video about that installing that Ford chock. And I got it installed and all cleaned and tested, and it was great. And I was sure that I was never gonna be in trouble in the Ford chock dimensional capacity. So in other words, I thought I would never have a piece that wouldn't fit in the chock. And now I have my first job on this lathe, and it didn't fit. So the first ever job that I got, and I was sure it would fit, but it's pretty much exactly 1 millimeter, or about 3/1000, though too large for the Ford chock. And as you can see, the job is turning the center hole of these 18-inch alloy rims about 10 millimeter or quarter inch larger. So I had to come up with a solution, and I will now show you how I did it. So my solution is here. You can see I have drilled some holes on top of the jaws. And what I'm gonna do with the holes, I'm gonna turn some pins that go in the holes and extend out for about ½ inch or 1 centimeter, something like that. And you may know how hard these actually are. And I think especially these jaws, since they're not some cheap Chinese jaws, they really seem to be very, very hard and tough. And I was surprised to see that they are actually probably hardened all the way through and not just surface hardened. Because they are equally hard to drill on the surface and also about ½ inch or a little bit more to 3/4 inch below the surface. So how I drill these, I first set them up in the chock, and using a ground edge I line them up in the vise and I tighten the vise. Okay, and then I have a solid carbide end mill, not an end mill, sorry, it's a solid carbide drill made by Seco. This it's a used drill, but this is the first time that I'm using this, and it's still in pretty good shape. And I think these drills are pretty much the only thing that can drill these hardened jaws. And this is the third one that I'm doing, and so far there seems to be no issues. I think I can now show you the first one. So I'm running at 280 RPM, which is very slow, but I'm not using any coolant. I think actually I could safely use quite a bit more speed even without coolant, but I really try to be careful. And I'm feeding down by hand, but I'm eliminating the backlash of the quill. It has actually quite a bit of backlash. If I tighten this lever, it has quite a bit of backlash. So I'm putting a little bit of pressure on the stop. So it's still not quite enough. Okay. So I'm trying to keep the pressure on the feed mechanism and not letting the quill drop down on itself. Because if I now let this quill stop go, see what happens. It drops down on itself. So by tightening this a little bit, I'm keeping the the forces where they're supposed to be, and no, there is no free play in the quill. And what carbide tools really need is rigidity, and that's why I'm doing this. Okay, let's go. The mill is pretty quiet at these speeds. Starting really slow. Okay, I think I need 2 hands now. Okay, and the result I have here in action now. Switch to neutral. So, I just drilled some holes to the jaws, and then I turned some pins that fit very accurately into those bores. And by that way I get about 15 millimeters or a little over half an inch of more capacity. And also I was thinking actually maybe I could turn these into threaded inserts, so I could put M8 threads in these pins and by Loctite lock them in there, and so I could have a place for threading something into, so maybe they could be used for like making another step in here if necessary, but I think I should have made these holes and pins larger, and also for larger threads, because the largest one I can fit in this is M8 8mm thread. But I think when I have this job done, it's gonna take a whole lot of time when I'm gonna need even these pins anymore. So if I ever need any more capacity, I will figure out something again, but for now this is working great. And I have already finished this first bore, and I use this inside caliper or a bore gauge, I mean Mitutoyo bore gauge, which I really like. I've never gotten into using anything else but bore gauges, because I really like these, because you get to see the dimension right away, and you can rotate it in the bore and push it back and forth and see what the dimension actually is. Where using a snap gauge you only get like one measuring point, and the target dimension is 66.6 millimeters, and I wanted to make a little bit larger, and I figured out that maybe 0 to +5 is an okay tolerance. So this is at about +1 or +2. And that's also how I'm gonna make the other ones. And I'm not gonna show you any turning, because there's nothing special about that. But maybe I can show you what it looks like to have a piece like this turning. And I have, let's see, I have actually whoops, I mean like this. So we got 180 RPM. It's turning pretty nicely. But it's not perfectly true. I indicated at the center hole within about 200ths of a millimeter or less than 1 thou. And the front face of the wheel is sitting on these chuck jaws, so it should be quite accurate also. But I guess the rims always have a little bit of run out. Okay, this is the first of the 4 rims that I'm gonna make. Okay, changed my mind, I'm gonna show you one pass. I have this set so that the larger bore goes about halfway through. So when this is at 0, I will stop. And I'm now taking about 2 millimeters of diameter, so 1 millimeter per side. And the feed is 1800s per revolution, which is maybe 8000, maybe. No, it's less. About 5000. 5000. No. Do the calculation yourself. It's surprisingly difficult. Okay, feed on. I'm loving this Sandvik boring tool. Now for the next pass. I'm still having a little bit of cold. Actually, this is maybe the longest cold, the most difficult cold that I ever have had. At least the one that I can remember. And I'm still having tomorrow off work to heal myself, but I figured I'm not just willing to sit inside on my computer all day. I really want to do something, and this is pretty light work, so I think it's better for me than just sitting and lying around all day. Okay. And by the way, something you wanted to see. Here you have it. This is my cylinder head resurfacing tool. And it's as simple as it can be. So it's just a big chunk of steel. I think the OD is around 200 millimeters or 8 inch. And then I just, you see, I made a slot for these keys to go in. And this is just a 40 taper shank with 27 millimeter cylindrical attachment possibility. And the tool that I have here, this is one of the first lathe tools that I ever got when I still had my old, very crappy, small Chinese lathe that I bought new. I think you've never seen a picture about that even. And I hope I will also never see a lathe like that again, because it was completely crap. But this lathe tool is from those times, and you can see I've just the tool had a M6 thread, so I just took a hex cap screw and a square insert that has a 6mm hole in it, and I just tighten it like this, and the lathe tool has a little bit of an angle, so it's just bolting it there, and when I loosen this I can also turn the insert however I will want. And what's the most important is the grind. I like to have an extremely sharp grind on these inserts. If you throw a late insert from a new insert from a box in there, it will not make nearly as good a finish as a hand ground one does. And I have had this tool for many years. This was maybe the first tool that I made for my old milling machine that you can see in some of my videos. It was maybe about 2 years ago when I sold it. I had just gotten this new milling machine when I sold the last one. But I still have this tool and I still like it. And actually I think it's the best kind of head surfacing tool that's possible to have on a milling machine. Okay, now I'm gonna let you go, and again I want to thank you for your comments and likes and everything, and dislikes also, of course. And I always read all the comments and I try to answer all of them. And if you have any questions, I will try to remember to answer them in the next video, but as you have seen, I tend to forget all of them when I film, but I will do my best. So keep commenting and liking and disliking and asking questions and everything. So thank you and bye.